Welcome back to the second part for importing data into SPSS. Today we are going to go ahead and look at how we will import data from an Excel file. And this is actually going to turn out to be a lot simpler than going from a .txt file as we did in the first part. And so prior to actually going into SPSS and going through the procedure to import, it's always wise to open up the actual Excel file you're planning to import in and just make sure it's formatted correctly. So if we look, I have this Excel file. This data is actually going to be from chapter 20 of your book. So if you'd like to follow along in your book and get a little more background on the data, I'll give an explanation for each of these variables once we have it imported in. You can see we have 5 variables, and you'll notice as we had done in part 1, they're actually using a 0-1 coding system for these pieces. These are actually going to represent some particular categories, which we will go ahead and label once we do get it into the system. But the most important thing is just to make sure that your data is formatted correctly. And so you want to make sure that your variable names are at the top in the first column. From here we can see that our variable names do look correct. They're only made up of characters A through Z. So you want to make sure that there's no spaces, no special characters or underscores or numbers for the first character in each name. And we're looking okay here. So if we go down, it's actually a bit of a larger data set that we're going to be pulling in. It has 223 observations once we subtract out that first row, which just gives the names. And with Excel, unlike the .txt files, you're actually going to have to close this file before you import it, or else you're going to get an application conflict. Essentially, it's going to say that this file is open, and so it can't access it. So we'll go ahead and close this file. And all we have to do to get this Excel file in is we're going to go to File, and then we're going to Open, and then Data. And what we're going to do is change the file type that we're looking for. So if we click here, it's going to catch any different type of Excel file, both older formats and newer ones, the XLSX. I went ahead and saved all the Excel files from the book to my desktop. And we'll go into chapter 20. And there's 2 formats of it. This is the older format, so for older version of Excel, you could import either one. Then we'll hit Open. And a new pop-up window is going to show up, and it's going to say read variable names from the first row of data. And since we did leave the variable names in there, we'll leave this checked. And then for the worksheet, it is actually able to read in prior to importing to figure out where there is data. And so it's saying in cells A1 all the way down to E224. And so that's correct. You can specify the range if you want to, but we want to bring in all our cases from there. So we'll go ahead and just click OK. And within that output window, it's giving you the syntax for how it actually does the import. Feel free to take a look at it if you'd like, and again are interested in the syntax and would rather use that. But you can see it was very quick to bring in this Excel file, and we have all of our data here. And now once you bring it in, you're obviously going to want to again check and make sure that all of our variables are defined correctly. So we'll switch over to variable view, and it's giving all our variables as type numeric because they are numbers. So it's automatically going to default to numeric for all of those. And then width, it's defaulted them to 12, which would match our columns, and they're all aligned right because they're numeric. And something that's very nice in how these were actually formatted within Excel for the book, you'll notice that it actually got the measures correct, and that our outcome variable, which is 0-1, it's actually using a coding system as nominal. And same with toxemia and steroid are also 0-1 nominal. And so once we get it in, we're just going to go through each of these variables and give you a little background on what they are. That way you have a little better understanding when we do the next pieces. So as I said, this is our outcome variable in our data set, so the one we're interested in figuring out how these variables might affect it if we were to complete some sort of analysis. And it's bronchopulmonary dysplasia, and if we would really like to, we can give a label to it. And again, this is just so people have a better idea of what the variable actually is. And so we can go ahead and give that label in there. And again, we could say 0 equals either yes or no. We could put not present, and 1 equals present. And then we can quickly do our labels. No missing variables for any of our variables in this data set, so we won't have to worry about this column. And the rest are correct. This variable, as you could probably guess, is birth weight. And it's going to be in grams. Another nice piece of labels is you can add what units particular variables are in. And this is again for both your use later on and for those that might use your data set. Values missing in columns right and scale are all correct. This is gestational age. This is going to be in weeks. All these columns will again be correct. Toxemia, and that is if there was an issue with toxemia during the pregnancy. We can just keep it the same as what the variable name is, but we are going to want to go ahead and just put a little note. 0 equals no, 1 equals yes. And let's put our values to this. And it is considered nominal since we only have 2 categories, so there can't really be an order with 2 categories in any case. And then we have the variable steroid, and that's if steroids were used during the pregnancy. And again, we have 0 equals no, 1 equals yes. And we'll quickly put in these values. And the rest of our columns are correct. So now we have fully defined our variables, and if we go back over here, you'll see we have the variable names, but if we stay hovering over one of these variables, we'll see the full label. And as you can see, we actually have the value labels on. So we can actually see the no and the yeses and present and not present. And you can go ahead and just put these back to 0, 1. And now our interest is looking at another transform, and we're going to look at recoding into same variables and recoding into different variables. So recode into same variables is if we wanted to recode toxemia from 0, 1, and instead we wanted it to be 1, 2 for some reason, and it's going to modify this variable. The difference being if we did recode into different variables, we're going to recode into different variables, but it's going to keep our source variable the same, and it's going to create a new, completely new variable for us, whatever name we give it over here. So you retain the old coding of the variable while creating a new one with that new coding. So we'll do recode into same variables. And let's just go from 0, 1 to 1, 2 as a simple example. So you're going to select toxemia, and we can just put old and new values. And we can say if the value is 0, we want it to go to 1. and then if the value is 1, we want it to go to 2 instead. We add that, and then we continue. And then if you want, you can also do it through if statements, and we'll go over that in a different lecture, but we can go ahead and just select OK. It's going to show you the recode 0 to 1 and 1 to 2 in the output window. And you'll see that all our 0s are 1s and all our 1s are 2s. So pretty simple, but again, it's going to change that source variable. So if you wanted to retain the 0, 1, then you would actually want to use recode into different variables. And for a little bit more of a complicated example with recoding to a different variable, let's say we wanted to take a continuous variable such as birth weight, and we wanted to actually categorize it. And usually if you're categorizing a continuous variable, it's going to be based on some sort of clinical information. It had to be clinically significant in most cases. So you want to say that below some birth weight, there's something important about that in relation to this outcome, and you're interested in seeing if that's true. And by categorizing, you can do different analyses than you would do with a continuous variable. For this exercise, we're just going to go ahead and split it into quartiles, and this is going to give us a chance to actually use some of these descriptive statistics and get you a little bit used to actually splitting your data into quartiles. There's actually 2 methods we can do this. We're going to do it in a longer way, and then I'll show you a bit of a shortcut, and I'll explain the differences in the results between the two. So what we'll go ahead and do is, if we wanted to split this into quartiles, we first have to figure out what are our cut points for the quartiles. So we have to go ahead and go into Analyze, and then Descriptive Stats, and we're going to go to Frequencies. Within Frequencies, we can select the variable we're interested in doing the analysis, which will do birth weight. And then we need to go to Statistics, and we're going to select quartiles. And the nice thing is, you can get some of the same summary stats out of frequencies as you could out of some of the other procedures that are in Analyze, that are usually if you're just looking at a continuous variable. So we could get the mean, we could get the median, and when we actually run this, it's going to give us a frequency count of each. So obviously that's going to be kind of long because we have a bunch of different values for birth weight, but really we're just interested in getting these quartiles. So we can go ahead and select Continue, and then if we want to see the frequency tables, we can, or we can remove them. So we can go ahead and remove, and then click OK. And you'll see it's nice enough to give us the number of observations, that we have 0 missing, our mean value for birth weight, our median, and then it gives our actual cutoff points. And so we have 890, 1140, and 1470. And so we're going to have to use these 3 values to actually create our 4 groups. And the way we can do this is right through our recode into different variables. So we go here, and we say we want to recode birth weight. That's going to be our input variable, and it gives a question mark because we haven't given a name for our new output variable. And we'll just call it birth weight underscore cat for categorized. We can give it a label so people know. We can just say it's quartiles. And then we just hit change. And now we see that coming in is birth weight, and out, based on how we recode, is going to be birth weight categorized. And now we just go to old and new values. And what we're going to go ahead and do is we're going to do range. And we know the lowest birth weight is 0. And we want to go up to our first cut point, which is 890. And we're just going to assign it a value of 0. We add that. And then we're going to do our next cut point. And luckily, since birth weight is discrete in this case, we're only getting it in units. There's no decimal places on it. Usually you'd have to use if statements if that wasn't the case, but since it is discrete, it's pretty easy just to use this area to do the range. So now we just have to go up 1 unit, 891, and we go up to our next cut point. We're going to set this to 1. And then we do 1141 to 1470. Value is going to be 2. And last we do 1471. Actually, we're going to have to exit out of here. A little bit easier is to go here and just put 1471 through highest. We put 3, so it's just going to be our fourth category would be 1471 up to the max value of this variable in the data set. We add that. And here you can actually do output variables into strings if you wanted. You can do some conversion also. If you had numbers that were strings and you needed them to go to numbers, that's also possible. But we can go ahead and click continue. And then we hit OK. It's going to again show you the syntax. It's recoding. And you can see we have birth weight category. And you notice the format, it's actually giving us decimals, which we're not going to be really interested in. So we can go back to our variable view, put the decimals to 0. And you'll also notice our measure is actually not nominal, it's ordinal. And so we're going to want to change this to ordinal. So we go back to our data view, and now we have birth categorized into 4 groups, 0, 1, 2, 3. And so again, this is just an example of showing how we can actually use this transform. You usually want some significant reason behind why you're taking a continuous and changing it to a categorical. There's a number of reasons, but we won't have to go into the details of those pieces. And so that's one way, and it's a bit long because you do have to run a couple procedures. Another way we could do it is we can go here, transform, and then rank cases. We go back to our original birth weight. We select it here. And then we're going to go to rank types. Deselect this and we say end tiles, which is essentially saying we want some sort of either tertiles or, in our case, quartiles. And then we hit continue. And then for ties, so essentially if there's observations 1, 2 or more that have the same value, how it assigns a rank to them. So essentially we're ranking them from smallest to largest. And so if there ended up being another 1500 in here, so if it's trying to rank them, how would it go about that? And it's just going to assign the mean rank to them. And we can leave that for this one. And then all we have to do, and we can take out, well, we can keep display summary tables. And then assign rank 1 to the smallest value. So it's going to take the smallest birth weight in here, assign it 1, then the next largest is going to get 2, and then 3, and then 4, and so on. We click OK. And it's going to say that our source variable is birth weight. It's using that percentile, that end tiles. Our new variable is called end birth weight, and then it assigns a default label. And if we actually go back, we will see that we now have end birth weight, which is going to be relatively close to what we have here. There's going to be a little bit of a difference, which I'll show you. The major difference is they assign 1, 2, 3, 4 instead of 0, 1, 2, 3. And just to give you an idea of the difference, we can again go back to descriptive and go to frequencies. And then we're going to take this variable out, and we're going to create the first variable we did on our own, and then we're going to take this one we did using rank cases. And now we want to display the frequency tables, and we don't need the quartiles of these or the mean or median. We just want to actually look at the frequency. and we click OK. And if you take a look, this is the one we did just based on quartiles, and we get 56, 56, 57, 54. So pretty even split of our data as expected. 25%. Here's our cumulative 50, 75, 100. And then here, you'll see that we get 56, 55, 56, 56. So there's a little bit of a difference. And that's because ranked cases does a little bit of a better job handling the ties than it is using this. So what is most likely happening here is one of our cut points, as you remember, those were 890, 1140, and 1470. Most likely what's happening is we have multiple observations that have those cut points, and so in this case it knows how to handle that when we might have 890 show up 2 or 3 times. But in this case, because we're doing it a little bit more roughly, we don't get as great of a split as we do using the ranked cases. So as a quicker way, I would recommend ranked cases, but definitely practice this way. Get used to getting all sorts of different values out of some of your categorical data, or as we changing your continuous to categorical. And so now you have a couple of tools for transforming your variable. You now know how to use compute variable, how to use Recode, how to use Recode into different and same rank cases. And so those are the main tools that you'll need to use with any data sets that you'll be analyzing in future homework. And that about covers the import. You won't have to worry about importing any other types of sources, only .txt and Excel. And if you go to the publisher's website, you can actually download the text files and the Excel files for all chapters, and that'll give you a chance to practice importing from both types if you'd like on data sets that possibly don't show up in your homework if you need some extra practice. And so for the next piece we will cover, now that you know how to use transform, what you're going to need as you start actually performing some statistical procedures and tests is to compute p-values. And we're going to be expecting that you compute exact p-values within SPSS rather than using a table, and we're going to show you exactly how you can go about that for any type of test that you're going to be responsible for throughout the class. And one last piece that we'd like to note is that for these categorical variables that we have created, as we have done with steroid and toxemia, if we go back to variable view, you are most likely going to want to apply labels to each of those values. As an example, for 0, you probably want to know that that's from 0 to 890. And again, this is so that if anyone were to look at your data set, or if you came back to it at a later time, you will know exactly what you did and how, and essentially hopefully you'll be able to replicate the process you did to create these variables if you ever had to do it again in a different application, or if someone else wanted to replicate your results. And so that should cover everything at this point. And if you have any questions, feel free to ask your TA. Have a good day.